Good morning, everyone. Thank you so much for joining a session. We at AWS User Group Mumbai are back with another session. This is one of the very interesting sessions. We are not going to have any presentations. We will just talk about the architecture and the hands-on CDK code. So that's what our session is. Let's talk about what is AWS CDK. And with me, we have a renowned speaker. She has done multiple sessions at early age of her career. You have seen in a couple of sessions in AWS User Group Mumbai itself, as well as in User Group India. Before I get her on the stage, let me make some couple of quick announcement. We will be live in next month with our community day virtual editions. There are many user groups which will be collaborating across India pen to talk about, to have some interesting discussions, bring some innovative sessions, right? So if you have not registered it, please do register. I'll share the link in the chat. So do register for the community day virtual edition, which will be on November 11th and 12th. You don't have to go anywhere. You just have to book your calendar, register yourself, and do it online. So do it right today. I'll share the link in the session. And for today's session, we have none other than Aishwarya Gupta. She's a DevOps engineer at District Technology and very well-renowned speaker for her DevOps as well as security contribution. She's an active community builder as well as a cloud enthusiast. Let me get Aishwarya on the stage. Hey, Aishwarya, how are you doing today?
Hi, I'm doing good. Good morning, everyone. Thank you for the introduction, Sanjay. So today I'll be covering everything, all from the beginning of CDK. We'll be going through a demo where we would be deploying a backend for AWS using just CDK, and we'll be step by step going through the deployment process. Uh, let's get into it. So what is CDK? CDK is a cloud development kit that is provided by AWS. It helps us deploy our infrastructure on AWS using our regular programming languages. So, what does that mean? That means is it's basically a wrapper. It's a layer of abstraction on top of the regular cloud formation templates that we deploy on AWS. What How it's beneficial to us is that we can write it in our plain programming languages all the way from JavaScript, TypeScript, C Sharp, or even Python. And writing in programming languages helps us in linting this code, helps us in testing this code. We can perform code reviews on this. We can perform unit tests on this, which was not possible on a scripting language like YAML or JSON. Scripting languages are also not very easy to debug. If you've written some cloud formation templates, the more complex it gets, the harder it is to debug unless you actually deploy it and you get an error. While if we use CDK in Python, we can just directly use PyTest or we can use PyLint and we can debug our code. CDK also provides some inbuilt commands and tools that we can use to debug our code and to understand the logic of our code. So let's get right into it. So first, I'll show you the code that I currently have. No need to get intimidated by this. I'll be explaining this line by line. So first, we'll go through the code structure that we have here. So what we are doing is we are deploying a serverless backend. So this is what an application basically looks like in CDK. We have a few files that will be there for all types of applications in whichever language you pick to write in. There would be an app.py. There would be some requirements that you would need to install for your application, and there would be the main programming file where you define the infrastructure. Since this is Python, there is a mandatory init file, and since in my application I'm deploying Lambda, there's a Lambda file. Now, before we get into the nitty-gritties of our code, let me just show you one diagram. So, instead of giving you some technical definitions and giving you some theory about it, I will explain this to you in the code itself. But just to understand on a high level how CDK is constructed, we can see that there is some sort of a hierarchy here. So the root construct here is an app. What an app is basically there is an app is like a concept in CDK which can consist of multiple stacks. Stack is similar to a cloud formation stack. So within an application, you can have multiple stacks or stack sets that you want to deploy on your AWS account, or even multiple AWS accounts. An application basically defines your the construct that you're trying to deploy on AWS, the infrastructure you're trying to deploy as a whole. What application does is application helps you manage the life cycle of your pipeline, of your CDK pipeline. So it helps you initialize it, it helps you validate it, you can also deploy it, you can synthesize it, which we will understand later what is synthesize, and we can also destroy it. If you are familiar with Terraform, these commands are similar to that. You can create an environment and you can destroy it using a simple command in command line, and all of your infrastructure would be taken down. Uh, so before you can deploy your application, there is something called as bootstrapping. So bootstrapping basically helps you set up the necessary infrastructure for CDK to work. So CDK cannot just directly work, right? There would be some files that you would need to store, some artifacts for your application that you would need to store somewhere that it can later reference to deploy your infrastructure. So we use a command known as CDK Bootstrap. What Bootstrap does is it sets up those required infrastructure on AWS. So I'll just show you on CloudFormation. Since CDK is an abstraction of CloudFormation, ultimately it just deploys a CloudFormation template, right? So if I go here, you see these resources that are created. As you can see, CDK deploys some things by default. We don't have to define this. All we have to do is run a command called CDK Bootstrap. It deploys basically an S3 bucket where all of our artifacts are stored, as you can see. Now, CDK itself does not have a charge, it's free of cost, but the resources that it may provision would have a charge. So, for example, this bucket and all the data in this bucket would have a charge. It would also have some sort of a KMS key attached to it, a customer managed key for encryption. Currently, what I've done is I have used a flag. So, let me show you that flag. Yes. So I've used a flag called no bootstrap customer key. So what this removes the CMK that is created to encrypt my S3 bucket, and it reduces my cost of bootstrapping CDK. Coming back to app, now that we've bootstrapped our application, now it's ready to deploy. So what does an app consist of? An app does not have an equivalent in terms of cloud formation, but inside an app, there are multiple entities called stacks. Now, stacks are directly equivalent to CloudFormation templates. I mean, everything inside stack, every concept inside stack is similar to what happens in CloudFormation. So, inside a stack, we can have multiple constructs. Constructs is a concept exclusively associated with CDK. So, what is a construct? Construct is nothing but a group of resources, group of AWS resources. Constructs can be of multiple levels and complexities. But currently, in this high level diagram, you can understand a construct as a group of resources that are interconnected to each other. So, as you can see, in our application, we have a stack, and in this stack, we have multiple constructs. This construct is defining simple an S3 bucket and a DynamoDB table. But this construct is defining a Lambda function which is connected to an SQS queue. So this is like a pattern. This is a frequently used pattern that is predefined by CDK that we can define using a construct. And we can connect these two constructs together as well. So this pattern can now be connected to this S3 bucket or this DynamoDB table. Using a construct will reduce the size of our code that we need to write. As you know, in a CloudFormation template, you would have to define everything from scratch. Every resource you will have to define all of its properties. Nothing is by default. But what a construct does is, in a construct, a lot of values are defined by default. You just need to define a few values based on the complexity, and that would reduce the size of your code and make it more readable, make it more easy to understand. And you can focus on your infrastructure instead of like the syntax or the semantics of your scripting language. Now, what happens is when this app of CDK is deployed, internally, this app is then what we call a term synthesized. What synthesized means is this app is internally converted into a CloudFormation template. At this point, the validity of your code is also checked. If there are errors, then the CDK command line will show you that there are errors in your code. Otherwise, it is successfully built into a CloudFormation template. This template is then deployed on AWS. And then from there on, after the handover to CloudFormation, everything is handled by the CFT. What would happen is, during deployment on command line, you can see the CloudFormation's status, but the infrastructure is basically provisioned by the CloudFormation from that point on. So this is an overview of what CDK looks like. Right. Now, going to constructs. So, as I said, a construct is basically a group of resources or a resource which is defined in CDK. Based on the complexity, it can be a single resource or it can be a group of resources. So, we'll go through the constructs, different flavors of constructs right now. The most basic construct is level 0 construct, which is just a resource. This is then inherited by all the other constructs, and there are features added to it. So what a construct is basically an AWS resource. That's how you understand it. Now, what is a low level or a level 1 construct? A level 1 construct, now keep in mind, all of these constructs in programming level is a library which you can import into your code, and you can use it to define different resources. So what is a level 1 construct or a low level construct? It is directly equivalent to a CloudFormation resource. As you know, in CloudFormation, to define a resource, you have to define it from scratch. All of its properties, all of its mandatory properties, and if required, any of its optional properties, everything from scratch. It is basically a bare bones resource that you can customize however you like. So this is directly equivalent to a CloudFormation resource, and when you import it into your code, it will look something like CFN bucket or CFN bucket policy. It will have a prefix of CFN attached to it. Now, what is a level 2 construct or a high level construct? So, the team at CDK has curated some pieces of code that help us define resources such that we just need to define 2 or 3 parameters in that resource, and everything is by default defined based on the high level use case. So based on the most used cases around the world, they have studied all the use cases that people use for each and every resource, and based on that they have provided us these predefined resources to us, and all of the basic properties are already populated. We can change those properties, but they are by default populated, and you can change the most customizable properties, such as in a bucket you can just add a name to it, you can define a KMS key to encrypt it, and everything else would already be predefined. So that is what a level 1 construct is. So today in our deployment, we'll be using level 1 constructs, all the level 1 resources, such that our code is short and simple and readable. Now, there is something known as a pattern construct or a very high level construct or a level 3 construct. What this is basically the team at CDK has taken some widely used use cases, and they have written predefined set of resources connected to each other in form of libraries. So for example, there's a load balanced EC2 service. This is directly something you can import into your code and use. So this would consists of a load balancer, an auto scaling group, a target group, and an EC2, all in a form of like a single set of resource that you can import into your code, define certain parameters here and there, and directly use it. uh, in a traditional cloud formation template, you would have to define all of these resources separately, then you'll have to connect them with each other with dependencies. Here, you can just directly import it into your code and use it. Similar to this, there are several use cases that are written into a pattern construct that you can directly import and use. So these are all the flavors of constructs that are there in a CDK application. Before I move any forward, are there any questions?
Yeah, there are a couple of there are questions, right? So one of the requests is if you can minimize your code editor a bit, you zoom in a bit, right, from a font size.
Mm-hmm.
Yeah.
Okay.
And the second question is from Shri. When do we need to use level 1, level 2, or level 3 construct?
Okay. So the usage completely depends on you. So there are multiple things that you need to keep in mind while using constructs. One is how basic or how complex your application is. If your application is a simple, let's say, S3 bucket, then you can use any of these to define your S3 bucket. You can use a simple cloud formation construct. You can use a predefined bucket, or even in pattern constructs, there's something known as a notifier bucket, which notifies you every time you create an object. So, if your use case is simple, you can use any of these constructs. But the more complex your use case gets, if you're defining an entire application infrastructure where there's a front end, back end database, you can use these predefined patterns to define your construct. This will help you reduce the size of your code, complexity of your code, and make it more readable and more debuggable. There is another factor that comes in here where how customizable you want your code to be. If you want it super customizable, if everything is predefined, if there's an SLA you're trying to stick to, everything you need to write on your own, then low level or high level constructs are a way to go, where you can define how you want to connect each of your resources, where you can customize your resources. But if it's something where you want to use predefined patterns and you don't really care about customizing it too much or getting into the nitty gritties, there you can use something known as a pattern construct, where you can just define these patterns and connect them to each other to build your application infrastructure. Hope that answers your question. Okay, let me just increase the size of my code here.
Yeah. And there is one more question we have from Vishal. Uh, yeah. How many levels are there in the CDK?
Yeah, so in terms of construct, there are three levels. There is level 0, level 1, level 2, and level 3. I mean, four levels. So basically, level 0 is just a plain AWS resource that we don't use in the code. It is basically something that is inherited in all of the other levels and used as an entity to add more abstraction or more wrapping around it, make it more simplified. So here there are four levels. There is a level 0 basic AWS resource, which is then inherited here in level 1. Then that level 1 is inherited here in level 2, and there is more customization added around it. And then these high level constructs are then inherited here and connected to each other in a predefined format that we can directly use.
Yeah, I think we cover up all the questions. Thank you. We can go ahead.
All right. So, I think all of this information is enough for us to understand what CDK is. As you can see here, this is also like the constructs on different levels. So, level 1, level 2, level 3. Now, we'll directly go into our demo I'll show you the architecture diagram that we're trying to deploy today. Oh no. Okay, let me show it to you here. All right. So this is what we are trying to deploy today. This is a serverless backend architecture. So it is, so as you know, serverless is like something that is clearly used a lot right now in terms of making our applications faster and easier to maintain and low cost. And there are multiple, I'd say, advantages of using a serverless architecture. There is also, I think, a serverless session, the entire series of sessions in serverless carried out by AWS user groups that we can go through to understand those advantages. But today, what we are doing in our demo are we are deploying a serverless architecture using CDK. So, what does this architecture consist of? It would be basically on top of this, there would be an API gateway. We'll be sending post requests to our API gateway where there would be a user ID and there would be a photo. So, what we are trying to do is basically using our backend application, we are trying to upload photos to our S3 bucket. But in our request, we'll be passing our photo in the form of a base64 encoded format. We'll send this request to our API gateway. Our API gateway will have a Cognito authorizer connected to it to make our requests more secure. It would be an HTTPS request as well as the authorizer will authorize if this user is present in Cognito user pool, and then the request will go forward. The API gateway will forward this post request to our Lambda function where the crux of our application is present, where all of our logic is present. This Lambda function will have some IAM permissions attached to it to be able to interact with all of these services. There would be an IAM permission. This Lambda function will then pass on this image and store it in an S3 bucket. And this metadata of each of these requests will be stored into a DynamoDB table. So we'll be provisioning all of these resources using CDK. Now, before I get into the code, let me just show you how to start with CDK. So let me just increase the size of this as well. How do I do that? Um,
Can you try Command Plus?
okay. All right, cool. Okay, I hope this is visible.
Yeah.
All right. So before we start with CDK, I hope all of you know that we can use CDK from our local as well as we can do it using by provisioning a virtual machine or an EC2 instance on AWS itself, which would be easier. So what I've done is I've set up CDK on my local. Before you set up CDK, your AWS CLI should be downloaded and configured on your local device or on your virtual machine. What I mean by configured is your access key, secret key, and your default region. All of these three values should be already defined for you to be able to use CDK. So once your AWS CLI is configured, what we'll do is we'll install AWS CDK. Now CDK is written in Node, so we'll use the npm. So npm should also be present in your device, whichever you're using, uh, to install CDK. Even if you're writing your code in Python, you will have to use npm to install CDK. So you can install it directly using this, where the latest version would be installed, or you can define the version that you want to install. And this way, you'll be able to install your CDK. Once CDK is installed, then you can initiate or instantiate your CDK library in Python or whichever language you're using to define your application. It could be Java, JavaScript, TypeScript, or C hash. So currently, our deployment is going to be in Python. So I've used this particular command to initiate my CDK library. Now there's a command called npm run watch that will help you, that will, on command line, it will watch for all the changes that you make in your application file that you can use something of a utility to monitor changes or differences in your code. Currently, I'm not using that. So now, uh, let me just show you CDK init. So here we can see all the options that CDK provides us, all of these commands. There is not a lot. It's a simple list of commands that we can use to deploy our applications remotely on AWS. So going through them, there is CDK list to list all the applications in your repository, in your current directory. Then there is CDK synthesize, as we discussed before. If you have an application where you've defined all the CDK code already, you can go in that directory and you can use a command called CDK synthesize, which will build a CloudFormation template out of all the programming language code or a Python code that you've written. It'll build a template and it'll print on command line. So you can check that template and you can further customize your application. Now there is a command called Bootstrap that we've also discussed. It will help you initiate your AWS environment such that CDK can run on it. So it will provision certain IAM roles. It will provision an S3 bucket where it can store all of those artifacts that you require for your deployment. Then there is CDK Deploy. It's a very simple command. You can use this command to deploy your application on AWS. Even if you don't do a CDK synthesize, when you run a CDK deploy, your CDK library will automatically synthesize your code, turn it into a CloudFormation template, and then deploy it on AWS. Then there is something known as import. You can use import to import resources that are already created on AWS into your application. Then there is something known as watch to watch your deployment. There is destroy, very similar to Terraform. You can use CDK destroy to deprovision all of those resources that you've put on cloud. You can just use this one command and you can delete all of those resources. Then there is something known as CDK Diff. So if you've already deployed your application on AWS using CDK, you can use, and if you've made some changes on your local or in your VM in the application code, you can use CDK Diff to see the differences that are there in the deployed code and in the code that is currently on your local device. Then there is multiple other commands. CDK init is also a very useful command. So if you don't have an application, if you want to try out like a sample application, so you can use the command CDK init. So as you can see, I have defined two ways that you can initialize an application in CDK. One is CDK init app, and then you write a flag language and you define the language you want your application to be in. And one is CDK init my app. So difference between these two is app would give you a very bare bones application, a very simple like list of code files where you'll have to define everything. So there is nothing defined in those files. You'll have to go in and you'll have to define values, you'll have to define properties, and then you will be able to deploy it. But if you want just a simple application that you can directly deploy on AWS, in that case, you can use CDK init my app and then you can define the language you want it in. This will create a sample application which will consist of an SQSQ and an SNSQ. And you can use the sample application to test out CDK. You can deploy it on AWS, you can monitor it, you can validate it, and you can destroy it. It is also helpful to use CDK init app to create a bare bones application, and then you can create your application on that basic structure of code that CDK has provided you with. Since we already have a code, so I won't be running these commands, but they are pretty useful if you're just starting with CDK. Once you initialize your app and you've written your code and it's all ready to go, then you do something known as Bootstrap to initialize your AWS account or your AWS environment, or you can use multiple such uh, flags as well. With Bootstrap, this is just one of the flags. You can attach multiple flags to customize it further. Now let me get to the code, the main code. So as we previously discussed, this is this is my code structure. This is my repository. This is my code structure. So there is a lambda handler where my lambda code is present, which is my application code. There's a serverless backend. This is my CDK app. Inside it, there's an init file, and there is my app that I have defined. This file that I have defined, and then there is an app.py. This is the uh, this is the top level, like this is the app, the CDK app, where I inherit my serverless backend application. Here I'm inheriting it, and I am initializing my app. All right, now there is also something known as CDK Json. Let me just close this. So CDK JSON is something that helps you. That is not something you need to define when you init your CDK app. This file already comes in, but after you make changes in your application, you would have to define all of this. So basically, here it defines how you would run your application. So since it's a Python application, I get a Python 3 app.py to run my application. Then there is some exclude. So when you push this code, what all files you need to exclude. And there is something known as context. So what context is basically, it helps CDK keep track of all the major changes in your code. So when you do a diff or when you change the code and deploy it again, CDK, it helps CDK to understand the difference in different deployments and to point it out. So all of these are breaking changes, right? So I've used API gateway in my code. I used RDS in my code. I've used Lambda in my code. So what is context? Context is basically a set of flags that is set to true or false, and it helps CDK track all the major changes in my code. So now, if I make changes in my code, I'll have to change these flags to true or false. If I am suddenly not using API gateway anymore, I will turn it as false, and it will help CDK understand the diff between two deployments. Yep, so that was CDK JSON. Of course, there would be a requirements.txt that you would have associated with your application. Before deploying, you would have to do a install requirements.txt. Currently, I don't have much. I have just CDK library and constructs, which are already there on my local, so I don't need to create a virtual environment. But in case of complex real world applications, you will have multiple Python libraries here that you would need to install. In that case, it is recommended that you create a virtual environment and then you do an install on the requirements.txt. All right. Now getting into the code. So the Lambda handler is my application logic, which we don't need to get into. We don't need to understand it. Basically takes my post request and it converts the image and it saves it into an S3 bucket. Right? Let me just open it. Yeah. So it's using SDK. Now I hope you understand the difference between CDK and SDK. SDK helps us interact with AWS services. CDK helps us define our infrastructure. So this Lambda function is using SDK. It's uploading metadata to DynamoDB, uploading image to S3, and in handler we are calling all of these functions. And getting to the main code, init file is empty. Then we get to the serverless backend stack.py. So this is our main file. This is our root file which is used to deploy our CDK application. So at first, if you see from AWS CDK library, we are importing all of these resources, all of these constructs. As you can see, they don't have a CFN at the start of them. So these are basically level 2 constructs. So this is just the standalone resources. They are not connected to each other. They are not a pattern construct, but they are also like a level above the basic cloud formation resources. They have some default values already defined. So I can just define 2 or 3 values and it will be ready to deploy. So as you can see, I am defining a cloud formation parameter here, exclusively I'm defining a parameter. So why am I defining this parameter? Basically because I am creating an S3 bucket in this code. Now, as you know, S3 bucket needs to have like a very unique name. Otherwise, your bucket won't be created. That's why I am accepting the S3 bucket name from the user, the name of the S3 bucket where uploaded images will be stored. So this name user will define in the deploy command, and then my CDK stack would be deployed. Then I'm using Cognito on top of my API gateway to define the Cognito user to authorize users to send requests. Then there is an S3 bucket, there's a DynamoDB, and there is our AWS Lambda, the crux of our serverless application. So here, as you can see, I've defined a class for my serverless application. Init will be my init function. Here I take a construct. I take the construct, and this is more of a Python specific code that you can understand by itself. But basically, I am inheriting some values. I am initializing some values. So here I define the bucket name using CFN parameter. This is a level 0 construct since it has a CFN associated with it. It is just a CloudFormation parameter. And all of the other constructs are level 1. So then I define a user pool. As you can see, it is so simple to define a Cognito user pool. It would be so complex in my CloudFormation template, but it's just these many 4 or 5 lines. In my Python code here, it is just defining a user pool. I am initializing it here. Then I'm adding a client, app client here, right? And I'm using a password. Then I'm defining an identity provider and IDP, which is the user pool itself. It can also be an AD of some sort. Then I am using this Cognito user pool. For my API gateway, I'm defining an authorizer, which will be present in my API gateway, which will authorize all of the requests that are coming in based on the user pool users. All right. So in these like 4 or 5 lines of code, I've created an entire Cognito user pool and I've created an authorizer using this user pool for my API gateway. Now we define a DynamoDB table. Here, if you can see, there's an ID that I have defined, a unique ID associated with my table. There's a table name, form data, and there's a partition key that I've defined. So name is based on the user ID, the metadata would be stored. So in just 2 lines, I've defined my DynamoDB table. Then there's a S3 bucket that I've created. So it's very simple here. It's an unencrypted bucket. So I've created an S3 bucket, unique ID, and the bucket name from this CFN parameter. All right. Value as string. Since we are accepting it on runtime, we convert it as string. Then we define our Lambda function. So similar to all of the above resources, there's a unique ID associated with it. There's a function name. There's a runtime, which is Python 3.7. Then I define the handler, since my handler is index.py, so index.handler. Then I define the code. Where the code is defined, I can directly write the code here if it's a very small code, or I can define the path where the code is stored. So the path currently is in the Lambda Handler folder. So I've defined the code here. Then environment variables I've defined, so bucket name and DynamoDB table name. So these 2 environment variables I've created in my Lambda function. And as simple as that, my Lambda function resource initialization is complete. Now what I'm doing is a set of IAM policies I'm attaching. So using these inbuilt functions, you can just add IAM permissions to your resources. So I am granting my Lambda function read-write permissions to my S3 bucket. I'm granting my Lambda function read-write permission to my DynamoDB table. And then for my API gateway, so here I've defined my API gateway resource. Simple, there's a ID, there's a format, it's a REST API, then it is connected to my Lambda function, and proxy is true. And inside my API gateway, I define some resources. So there's a path called slash form. Under this path, there will be a post method. And in that post method, there would be an authorizer present, as you can see. And it's as simple as that. Here, my API gateway is done. So this is basically the crux of my CDK application. Here is where I define all of the resources. As you can see, it is simple, it is readable. You can edit the syntax. Your IDE will tell you if there's a syntax error. You can when you run this code, when you run a py test maybe on this code, uh, you will find out if there is a logical error or something, which you won't be able to do in a scripting language like JSON or YAML. But here you can very simply do that. Now, after I've defined my crux of my CDK application, I just, in this very simple code, I inherit it and I initialize my CDK app. Now, this file would be called when when CDK would be synthesizing. So this file will be called. It would call this file in turn, and they will create a CloudFormation template. All of these things that I have defined. Now, as you can tell, this is just a 50-line code, but the CloudFormation template for all of these resources would very well stretch to maybe 200 lines. So as you can see, already we are getting so many advantages out of CDK. Now let me run some commands here. So I have already bootstrapped my application, but let me just do that again. So, bootstrapping again and again, it won't overwrite or it won't cause any errors in your application. What it would do is it would just update your previously bootstrapped application. If there are any changes, it would update it. If there are no changes, it would do nothing. So, if I do a CDK bootstrap here, right? So I can define a stack here in front of it. So as the stack name here is serverless backend, the stack name is serverless backend stack, right? But since my application consists of only one stack, I don't need to define the stack name. It'll automatically know. So if I run CDK Bootstrap, it'll give us some very pretty output here. Let's just wait for that. And then we can see on the console as well that it has created a CloudFormation template. Let me just go to the console meanwhile. As you can see, I have already bootstrapped my environment. So there's a CDK toolkit CloudFormation template that is defined. So this toolkit template would just initialize my AWS account or my AWS environment with some resources that CDK internally needs to use. We won't be using them directly, CDK would be using them. So all of these resources, IAM role, SSM parameter, an ECR repository in case your application consists of a Docker file, then an S3 bucket to store all the artifacts, and a bucket policy. So here, if you can see, I have not defined any trusted accounts since my environment is not multi-account. It is just one account that I have configured in my AWS CLI. So I have not defined any of these values. But it has, as you can see, I have not defined any IAM role as well. So it is using a default execution policy here, admin access. So the access key and the secret key that I have used to initialize my AWS CLI has administrator access. So it's using this policy, administrator access, to initialize my environment. So as you can see, we can pass this particular flag to CDK Bootstrap to customize these policies. I can use a more restricted policy, least privilege policy, to initialize my environment. So as you can see, there were no changes. So therefore, nothing happened. And I can run this command as many times as I want. AWS does not recommend that you delete this stack and you bootstrap your environment again. Excuse me. Because if there are any existing pipelines, CDK pipelines, then they won't be able to run if you delete this. Therefore, you can just directly run this command again to update. If there are any updates, it will update it. Excuse me. So are there any questions up till now?
Guys, please post your questions in the chat. I don't see any new questions so far, but please feel free. If you have any questions, please put it in the chat. Aishwarya will be happy to answer them.
All right. So now that we have bootstrapped our environment, our CDK application is ready to go, ready to deploy. So what I'll do is I'll do a CDK synth or a CDK synthesize. Any of those commands work. So when I do a CDK synth, oh, I'm sorry, SYN. It will convert my application into a CloudFormation template and it will show the same to me on this like on this UI. Just 1 second. All right. As you can see, this is my CloudFormation template that CDK has given me. As you can see how long this template is compared to my 50-line code. This is the entire template. Starting from all the way here, it defines all the resources. It even defines the parameters, the bucket name, bootstrap version. Bootstrap version is something that comes after we do a CDK bootstrap. It will directly fetch this value from SSM parameters. Then there are resources, the user pool, as you can see. This is entirely the code of the user pool. S3 bucket. Then this is entirely the code for S3 bucket, the IAM policy that is attached to it. This as you can see how long this code is and how simplified it would be here, where I've just written something like this. Grant read write. So a single line code is defining my IAM policy. I don't have to worry about it. Whereas in the CloudFormation template, as you can see, it is like a very long piece of code where you have to define each and every policy that you want to attach to your role. All right. So this is my CloudFormation template that we got out of my application. And there are conditions as well. So these are very complex conditions based on the region, how you want to deploy it, that I didn't even have to define. CDK considers that by default. All right. Now that I have synthesized, what I can do is a very cool command called CDK Doctor. It tells me if my environment is ready to go. So or if there are any errors in my environment. So as you can see, my CDK version, my AWS environment variables that I'm using. So these are defined by CDK itself. If I wanted, I could have defined my region here, my default region, and my access key secret key here itself. But since they are already configured in my CLI, I don't need to define them here. And there are no CDK environment variables. There are just AWS environment variables that we are using. So this command just tells me what prerequisites I have already set up and if there is something that I've missed. So this is defined. So what I'll do is now I'll deploy my application. Let me see. So deploy my application. There is, I think, I need to define the bucket name. All right. So let me just go here and check my previous commands. Yeah. So CDK deploy, mostly it will be just CDK deploy and the name of your stack. But since I am fetching my bucket name explicitly as a parameter from the user before deployment, I have to define a parameter dash dash parameter flag here, upload bucket name as I defined in the code. And this is the bucket name that I'm defining. So let me just change this so that I don't get any what do we say, conflicts. So this is a unique bucket name that I've defined, and now I'll do a deploy. Before deploying, it'll ask me if I really want to deploy. It'll give me a summary and it'll ask me if I want to deploy my application, which is very useful in case you run this command and you're like, oh no, I need to make this change. It'll ask you first, it'll confirm from you, and then it'll deploy your application. So now, as you see, at deploy as well, a CDK internally synthesizes your application. It'll convert it into a CloudFormation template internally. It takes 18 seconds to do that. Then building assets. So it's building my assets, and then it gives me this summary. So this resource is created DynamoDB table. It has all of these, I think, all of these permissions. This is the principal. Then CloudWatch, same for all of these resources. Lambda function, I have all of these permissions. API gateway permissions. Then there's a service role attached to Lambda function, assume role Lambda. Then for same for S3, there's an IAM permission like associated with S3 that would be connected to my Lambda function. So these are the IAM policies. Then these are the resources that would be created. So there may be security related changes not in this list. All right. So now it is asking me, do you wish to deploy these changes? And I'll go with yes. So now it's saying deploy. So as soon as it starts publishing, it is basically publishing my CloudFormation template to AWS, and now it started creating my CloudFormation change set. Now I can directly see it on my UI, then that there is a CloudFormation template that is being created. Serverless backend stack, as I had defined in my code. The stack is being created, all of these resources. So now CDK has handovered all of the resource creation to CloudFormation, and now CloudFormation will handle the resource creation. This does not mean that you don't have visibility into it. As you can see here, oh, these resources already exist, as you can see. DynamoDB table already exists. Then, all right. So I'll just go to DynamoDB and I'll delete that table. I'll go here and I'll delete my table. This is happening because I had already tried out this tag before. So this table was created, and as part of destroy, this table was not deleted. Similarly, if in my S3 bucket there was some data, then destroy would not delete my S3 bucket, since you have to first empty your S3 bucket before deleting it. So DynamoDB table I had to delete manually. Now I'll try to do this again. As you can see, it gives me very detailed errors of why my stack failed. So we can directly use this to debug my code or debug the deployment. So now I'll try this again. Let me just see. I might have to destroy this particular stack since it's in rollback complete state. Let me just do it from here. Let me exit out of this. Let me do a CDK destroy. It takes a few seconds to load since it's there's a lot of levels of communication happening here. This is a very high level abstraction. In the backend, it is interacting with AWS CloudFormation. CloudFormation is interacting with your resources, so it takes a while, but it is like there is a lot of visibility that you directly get from your command line interface. You don't have to even go to your UI. As you can see, my stack was deleted. If I refresh, my stack is gone. If I check DynamoDB, there is no table here now. I'll just quickly check S3 as well. So S3 bucket was created. So I'll just delete it. These are some things we would need to keep in mind when we are doing CDK destroy. Similar to Terraform, I think Terraform as well leaves out certain resources that have some intermittent like inclusive dependencies that we have no choice but going in and manually doing it. Even in CloudFormation, if you are creating an S3 bucket in CloudFormation, you'll have to first manually empty that bucket and then you'll be able to delete that CloudFormation template. So now I'll run my deploy again, and I am making my bucket name unique just in case, since I've just deleted it, so that there is no conflict. It'll again synthesize my application. It'll give me a summary and it'll ask me if we want to go ahead with that. So this is in delete complete state. Yeah, I got the same summary again. I am summary. Now I'll go with yes. Now it is deploying my CloudFormation, publishing it to AWS. And now we can see the stack here. Currently in review. After that, it'll start creating my resources. Alright, now it's creating my resources. So if I go in parameters, as you can see this Bootstrap version, right? This version was created in my CDK toolkit. It created this, let me go to the SSM parameter. So this Bootstrap version was created in the CDK toolkit that it's directly fetching in the parameters here. And this upload bucket name I have passed during deployment. So in the events, now we can track our deployment as well as we can just track it here. As you can see, it is giving me the a very prettified UI here. It is showing me what is happening in my stack. All right. It is giving me this scroll bar type of a format of showing how my change set is being deployed. Very similar to the UI. So the new DB table is created, my S3 bucket is created. So if I go to S3, this bucket is now created. If I go to Dynamo, my table is created. If I go to Lambda, I can either go there, since in my account there is not much to see, it's easy to track this, but we can go from here as well. I'll go here to Lambda functions and I'll go to my Lambda. Directly opens my Lambda. As you can see, it already has the API gateway trigger associated with it. And this is my code. This is my index.py code. All of this I had defined already in my code. Some of these values were by default. And in the environment variables, as you can see, these two values were created. So table name and bucket name. And this is not inside of VPC, but using CDK, we can also define a VPC and we can make it a private Lambda function as well. As you can see, I think my stack is now created completely. If I see my, here, if you see, as form of output, my stack is already created. This is my API gateway. So my stack has now returned this endpoint to me, this API gateway endpoint to me, which is very clever. I don't have to go to AWS, go to my API gateway and go to its stage and get this. I can directly get it from here and I can send requests. And this is the stack ARN. In case I want to track my CDK deployment on AWS, it gives me the ARN that I can open this stack here. The total time took was 167 seconds. Now let me just go to API Gateway just to cross check. I'll go to my API Gateway. This is my authorizer, user pool, API. This is API Gateway. As you can see, there is a /form path in which there was a post created. In the method request, it is connected to this authorizer, which is connected to my Cognito user pool, and it is calling my Lambda function. It is calling my Lambda function, form Lambda. All right. So all of this is done. If I go to prod, this is the URL which I was getting here as well. The same URL. All right. So now, since my application is deployed, we'll just test it out and see. Meanwhile, if anyone has any questions, I'm happy to answer.
No, Aishwarya, I don't see any questions so far.
All right. Okay. So there are, since this is a backend application, it is assumed that you would have a front end application where you're using Cognito, where you can initialize your user. If you don't have a front end, what you have to do is just manually go to your Cognito user pool. This is my user pool. I'll go here and I'll create a user so that I can send requests to my API gateway. So I'll create a user. Username can be my email. All right. And send invitation in form of an email. If you don't want an invitation, you cannot send it. I'll send a simple password. This password needs to be in compliance to the rules and regulations that the password should follow. It can not just be password. It has to have a capital letter, small letter, number, something like that. So I've defined it here. I'm not giving a phone number and I'm giving an email ID. So email is verified. So I create a user. So when we create a user in Cognito, it is always in a force change password status. So now we'll have to run a CLI command to approve or to validate this user, which is right here. This is very specific to this use case. So we'll give a link to this particular code that we have deployed, and you can follow these same steps. These are also present in the README for this code. You can follow these steps and you can initialize your Cognito user pool. So let me just get my user pool ID from here. I'll get it and I will populate it here. I have to define the username, which is the same, and I have defined a password, very simple password, which is not recommended, but for this use case, I have. All right. So this is the command that will help me set user password, set my user's password, and make the user permanent. So when we create a user, they have a temporary password which they need to change. So I won't be able to use that user. So now that I have run this command, now my user is confirmed. The account status for this user is confirmed, and I have set a permanent password for this user. Cool. Now I have to run one more command to fetch the Jwt token. So Cognito authorizer, how do you use it? How do you use an authorizer in API gateway requests is you pass a Jwt token to API gateway, which it would then decrypt and it will check those values with API gateway, and if it's right, then it will make your request go forward. So I'll just fetch a Jwt token here. Let me just change my user pool ID. Changing the user pool ID. Client ID also I need to change. Okay. So as you can see, I've created an app client here. Right? Without the app client, you won't be able to use this Cognito user pool. There has to be an app client. With the app client, there would be a app client ID and an app client secret associated. So I just need to pass the app client ID, which will be included as part of my Jwt token, and then API gateway will cross check that with Cognito. This is my app client ID. This is my username and password, which is same. I'll just copy this command and I'll run it. The user, okay, this has to be region. My bad. Just the region. Just passing the reason and giving the client ID, it will be able to recognize which Cognito user pool to consult to. As you can see, I got my ID token here. It is a bearer token. It is valid for 3600 seconds. So I just copy this token here. This is an older token that I got. So I just replace this with my new token. My token, I'll just confirm I copied the right thing. Cool. All right. Now we're ready to send a request to my API gateway. So as you can see, this is a request that I previously created. I'll create a new one. So it'll be a post request since we are posting an image, and I'll fetch the path from here. This is my API gateway URL. At the end of that, I just need to append form. So this is a URL that I need to hit to send my image. Now in authorization, I will add I can add either a bearer token here, or I can go to headers. I can create authorization and I can pass the token here. So I'll just copy this value. Go to postman and I'll define it here. Cool. Now I have my authorization header. Now I need to define my body. Body would be raw and it would be of JSON format. Alright. So let me just see what body I passed previously. Okay, there would be a user ID associated and there would be this base64 encoded image. Alright. Now I'll use this base64 encoded value. Since this is a very big value, I'll just directly use this one. I'll go here, I'll add this here, and I'll change my user ID. Right? This is my body. This is my header, authorization. I'll just remove this. I have an auth here, otherwise I can define it here, not both. And this is my body. Alright. What this should do is, this particular photo that I have encoded in base64, it should push this image to my S3 bucket. Now I'll send this request. And it gives me a success response. If we check the headers, this image would be successfully uploaded. Now let me go here and check my S3 bucket. I'll go to my S3 bucket. As you can see, there's a PNG image here. I'll download this image, open it, and this is the image. This is the image that I encoded in base64 and now it's uploaded to S3. Similarly, in my DynamoDB table, there would be an entry. Alright, so we can query our DynamoDB table and we can fetch that entry from here. As you can see, there was some activity here. Alright, cool. So this is basically my CDK application fully functioning on AWS. I did not do anything on the console, minimum changes on the console, basically just to delete the previous deployment. Otherwise, if you were setting it up completely new, you don't even have to touch the console. All you have to do is run commands from here and you will be able to deploy your application directly from CLI. Now, what should I do? If I do a list, It will show me what all applications I have currently. Not, sorry, CDK list. There's just one application, so it will just give me that one application. Meanwhile, if anyone has any questions, do let me know.
Yeah, Aishwarya. So we have one question from Karthik. Can we create resources conditionally based on stack, create, update, or delete?
Um, I'm not sure I understood the question. So basically, if the stack is being updated, uh, do we want to add a condition? If the stack is being updated, then we should not touch a particular resource. Is that what the condition is?
Yeah, I think the question seems like the same based on the life cycle of stack, how we can conditionally handle the resources.
Yes, yes, it's definitely possible. In CDK, there are multiple libraries where you can define. So, in CloudFormation, we are very limited to conditions, to add conditions here. So, there are two types of conditions. One is which you define in the template. Here, the conditions. So, if you see at the bottom, we have certain conditions, right? CloudFormation, we are very limited to how we define conditions. But since in CDK, we are using a programming language, we can use all sorts of condition. We can use if, we can use a while loop, we can use a for loop to define our stack. So this is one type of condition. So, another is which we define in the stack properties. So here are some things that we define, right? So something in a stack policy that we define, where if stack is being updated, then you should not update the S3 bucket or delete and create the S3 bucket, stuff like that. So that is also possible. Would need some exploration since I have not used it yet. But yes, you can definitely look into it. All right. As you
There's
can
one more,
see, yeah.
so there's one more question what we have. How can we update or modify created resources with CDK? This is from Ajay.
Yep. So, for example, now my CDK application is deployed on AWS, right? And I go in my code files and I make some changes. Change something. And now I want to deploy that change again. All right. So what CDK does is on CDK deploy, it creates a change set. All right. So we don't need a separate command to update my application. All I can do is I can do again a CDK deploy and it'll update. If there are any changes in my code on my local repository, it'll make those changes in my stack set. It'll create a change set here and it'll make those changes. So I can use a command called CDK Diff. What it'll do is it'll compare my local files with my deployment on AWS. It'll show me what changes are there. And if those changes are good, then I can do again, I can run a CDK deploy and it'll update my stack. So as you can see, it has detected this stack and it will show there are no differences. So in my local, I've made no differences in the code. Otherwise, if there are a list of differences, you can check them, you can approve them, and you can directly run a deploy, and all of your changes would go back on CloudFormation. All right. Okay. So now, as you can see, our stack is deployed, everything is running correctly. Now I want to decommission my stack. Without going here, I want to decommission it. Now, since we are using an S3 bucket, in my case, I will have to go to the S3 bucket and I will have to delete whatever's in it. I'll have to delete this. Otherwise, my bucket won't be deleted. This is a limitation with AWS. I've emptied my bucket. Now it should be deleted. In case it is not, we'll have to go back and check. All right. So now I clear and I do a CDK destroy. Spelling mistake. All right. Now again, similar to CDK deploy, it'll give me a summary and it'll ask me if I want to destroy my stack or not. which is very important in case we run this command by mistake or we want to take it back. We always have an option of saying no after it gives me the summary. See, as you can see, it's giving me, are you sure you want to delete this stack? I say yes. And now if I go to my cloud formation, it's in delete in progress state. All right. So we can see here also in a very good format here. It's very readable. Unlike how CLI is usually, we can see here the status of my CloudFormation stack. So it's deleting all of these things, even the API gateway methods, resources, Lambda function. So all of this is getting deleted. We can track it here as well. As you can see, some of the things, the deletion was skipped. Oh, that is because in my user pool there is a user. So its deletion was skipped because I did not delete this user. So I need to disable the user, then I need to delete the user. So now since the user is not there, if I would have done destroy now, my Cognito user pool would have also been deleted as part of destroy. Okay. Just for fun, let me see if I run the destroy command again. Will it delete all of those resources? It probably won't. It won't detect a stack itself because it's gone. It's deleted. Let's see. Lambda function has been deleted. API gateway has been deleted. S3 bucket is still there. We'll have to delete it manually. Alright, DynamoDB table is also still here, probably because there is data in the table. So we'll have to delete it manually. Alright. As you see, it's detected the stack. Now it's saying if you want to delete and destroyed. Now let me see if my user pool was deleted. It wasn't. All right. So one thing we have to keep in mind is for any of such resources in which we create multiple sub resources in a user pool, we create users. In S3 bucket, we create objects. In DynamoDB table, we create entries. Then their deletion would be skipped because they have a condition where they need to be empty before we can delete them. All right. So this stack is destroyed, and we are set back to the initial this CDK toolkit. So now I think that is the end of the demo. All of these files we have gone through. We were successfully able to deploy a serverless backend application, which is this application with all of these services, IAM, DynamoDB, S3, Cognito, API Gateway. We were able to test it using a request from Postman, and we were able to destroy it successfully. Are there any questions?
I don't see your questions, guys. If you have any questions, please put in the chat. I think the demo is almost done. If you have any questions, if you have any other doubts around CDK, which is not part of the sessions, and you want Aishwarya's help, I think so far we know she is the expert here, even among all of us in terms of CDK. So please put your question in the chat. She'll be happy to answer that.
Meanwhile, I'll just delete my bucket here.
Sure. Yeah. And in meantime, I just want to recall, as I mentioned at the beginning of the session, the user groups across India, a couple of user groups are going to collaborate and going to host a virtual community day, which is on November 11th and 12th, 2022. The link for the registration I've put in the chat. I'll post it again. Please do register today. It's going to be a fun and interesting sessions by different industry experts, different renowned speakers around serverless and all. You have already seen things coming out around the speaker lines, and there are many new announcements that is going to be follow up. Just want to let you know some surprises in upcoming weeks, like who are our speakers. We have all done around it. You'll see those announcements coming out very soon about the speakers, the workshops, and kind of stuff. So please do register today, as well as please do follow AWS User Group Mumbai. We are across all the social media platforms, whether you talk about Meetup, Slack, LinkedIn, Twitter. All the links I've posted in the chat. Please go through, scroll up if you have missed out the links, and please do join today. I'll also post all those links in the comment form of this video by end of the day. So if you have missed it, you're not able to find it out, you can go through the comments and get the link. Please do register. Aishwarya is also our member of User Group Mumbai itself. I just want to call out. So if you have any questions, you can still reach out to her and DM her on the Slack. You can reach out to me, or you can reach out to other members who will be happy to help you. As well as we do have some interesting sessions coming out, which will be very specific for the people who are the members of AWS User Group. Those announcements are going to be followed very soon. You want to be part of that? Please do register today for AWS User Group Mumbai. So I see one question. What's your experience using CDK compared to something like Terraform? Interesting. I was expecting this question coming out today.
Well, basically, Terraform definitely has more flexibility as compared to CloudFormation. Definitely, but again, Terraform is written in a scripting language. So there it limits on other like various functionalities of a programming language where like Python is something everyone would know, Java is something everyone would know based on the field that you're working on. It is easier to understand. You can debug it more easily. You can run tests on it. You can review it. Unlike a Terraform code, which would be much larger, much complex, much harder to debug as more complex it gets. So yes, while Terraform has more flexibility, while compared to CloudFormation, it is definitely not better than CDK. That is my experience. Sanchit, anything you would like to add?
Sure. Thanks, Aishwarya. So I think I completely echo what Aishwarya mentioned, right? Cloud formation, Terraform versus CDK. If I talk about CDK, has been one of the very good uh, since coming out closely working from the DevOps, the data lake, and ML. I bring all those flavors I've seen. Not just the data guys, not just the platform guys, even the machine learning guys have also adopted CDK. And one of the reason behind is Python, because many people are very well versed with the Python programming, the TypeScript, if I talk about the software engineers, right? Java, if we talk about. So there are, the support of this programming language really helps the folks who doesn't come from the background of DevOps also to adopt CDK. That's one of the very interesting thing coming out CDK. And second things, the things like what you generally do of update the resources in Terraform, Bootstrap, have versions, those are the same thing what you can do in CDK. So from terms of how your environmental life cycle of the resource have been handled, same what you can do in CDK, and the code itself is very compressed. That's the cherry on cake, I would say. Like the same example which Aishwarya mentioned, right? If you see the Terraform equivalent, I mean the cloud formation equivalent in YAML of that code of CDK, the CDK code was 50 lines, whereas the cloud formation in YAML, which is again, YAML is a very beautiful way to write it compared to JSON, right? The YAML itself was easily above 100 plus, right? So that helped us to develop or code the infrastructure in a very agile as well as rapid way. So that makes CDK much more interesting. And I'm pretty sure the way this entire CDK community has been active, the AWS is seriously taking this forward. This reinvent, I think we are pretty much close to reinvent. We'll see many other announcements coming out around CDK, as well as the new development coming very soon in 2023. So I'm pretty good, and I'm looking forward that CDK is going to be the promising tool in DevOps ecosystem. So thank you for answering the previous question. Any experiences using CDK for Terraform, Aishwarya?
CDK for Terraform. Yeah, I think CDK has offerings to write for like there is a library, completely different library to write for Terraform there's a completely different library for Kubernetes. So you can use those to abstract a Terraform code to abstract Kubernetes deployment files. I have not used them, but I think Sanchit could add on to that.
Yeah, no, I think that's correct. So CDK again, the whole idea I said, right? The CDK, this entire initiative or project from AWS is to support all the developers. I think the first phase, which I talk about, the developers who actively come from a programming language. But let's say you are a DevOps engineer and you want to leverage and continue Terraform, but in a CDK fashion. So that's exactly AWS don't want to leave any of their developers with the bad taste that no, CDK is not meant for us. No, CDK is meant for everyone. So you're coming from CloudFormation background, you're coming from programming, or you come from Terraform. That's exactly, you will see CDK Terraform coming out there. Now, this is a very interesting collaboration where you can see CDK and Terraform is collaborating together to do it. So yeah, pretty much I would say this is something interesting to come around stuff. But majorly my experience also, as Aishwarya mentioned, has been more using Python stack with CDK, which I've seen a lot adoption. But again, I'm not saying that people are not using CDK Terraform, but that's very coming up thing, I would say, recently. And you will see that many things coming out on Terraform side also, like the fans who are pretty much very good with Terraform. You'll see many other things also that has come up in last couple of months. If you talk about the landing zone, right, which was the entire multi-account strategy to handle. Previously, it was very much into the cloud formation ecosystem. Now you will see AWS has also allowed Terraform version of account factory provisioning and all, right? So I would say the path is very much right of AWS. We want to focus on simplifying the life of DevOps engineers. So you go with CloudFormation, you go with CDK, you go with Terraform. Just follow infrastructure as a code as a best practice. Don't worry whether you come from any of the environments, but infrastructure is the code, is the go to go where you come as an infrastructure, whether it's in machine learning, whether it's data lake, or whether it's a DevOps platform. Please do follow infrastructure as a code, CI/CDs, and those kinds of DevOps principles. So I think there's some off topic, but I would say interesting thing. Uh, if I'm a knowledgeable about something but struggle to articulate it clearly, how do I approach it? It caused me a lots of problem to accomplish it. Given that you both are an excellent speaker, kindly offer some advice. That's a very interesting question. Like I mean, something very off, but very close to me. So if I talk about this question, 3 years back, I was on the same lines what you're talking about, that how you can express very clearly about what is going on, right? What's exactly the technology all about, or how we can do it. Aishwarya is laughing because she has closely worked with me in the past. So she was my ex-colleague, so she knows how exactly things has been with me, and now it has been, right. One of the thing I would recommend is try to engage yourself into different communities. That's the whole idea of community. The community is not only meant for learning AWS, okay? It's even about your self development. That's what I saw a big change in myself. If I talk about in last 3 years, I was very I would say not very open, very shy person. Talking about in such public forum was not my style of way, right? I was very good, knowledgeable, AWS certified, but not very open, right? So things like I started following is more of reading around it, more of following the speakers, renowned speakers, right? And again, it's not just limited to AWS speakers. I would say community speakers, how they try to interact with the people, what are the different scenarios they get into it, how they handle those scenarios, right? And as well as go reach out to AWS communities, be part of them, because AWS community, as I mentioned, is not just learning AWS, it's about the overall development via different sessions you talk about, or you talk about how to host it, how to talk people, and also technical, which comes by default. So those are the couple of things I would say. Be more active in a community, follow different community speakers, and try to put yourself into different scenarios and see how exactly you can adapt to it. Those sessions for sure will help you to articulate your things which you're thinking very clearly, and people will do respect that. Aishwarya, do you want to add anything?
No, I completely agree there. With the help of Sanchit, with collaborating on multiple such demos inside and outside our workspace, we were able to. I was personally able to grow a lot, develop a lot of confidence. Of course, there is a lot of practice and a lot of preparation that goes behind it, but it's only with starting somewhere that you actually grow. So, starting with a small session somewhere, maybe with a group of colleagues, maybe within your company, it helps build a lot of confidence. Of course, as well as knowledge that Sanchit mentioned, following speakers, following articles, following AWS in general. Having knowledge around a topic also gives us a lot of confidence.
So, guys, if you have any other questions, we'll have a couple of more minutes. If you have any other questions, please post in the chat. We'll be happy to answer. And I'm just flashing the link for the registration for community day. Same is in the chat. You don't need to type it, please. It is in the chat, as well as if you have not registered, register it today itself. Well, a couple of more minutes, and then we'll wrap up the session for today. Cool. I see. I think, again, need not to say, it was a wonderful session by Aishwarya. I was very optimistic or overconfident, I would say, on her from the start itself when she accepted our invitation to be as a speaker. But yeah, the session cannot be completed without a wonderful audience. Thank you so much. I would appreciate all of our audience to be so engaged, asking all sorts of interesting questions, things like, okay, how CDK versus Terraform and other kinds of stuff. Those are all very interesting questions, and I really appreciate you guys took out the time in your morning to join us, ask those all curiosities, all your questions, right? I would again request everyone, please join AWS User Group Mumbai. I will personally ensure that we get some interesting sessions out this by in this month, October itself, as well as please do join for Community Day, which will be on 11th and 12th of November. And yeah, you also do register for reInvent. The reInvent is almost there. We are a month and a half away from the reInvent. It's going to be live online, as well as people who are traveling. The registration for the seats will open from October 11. So in any form, any shape you're going to be participating in reInvent, do register for the same. And Aishwarya, thank you so much once again to be a part of our user group Mumbai, as well as spending our time from your schedule to help us to learn about CDK. Need not to say, it was a wonderful session, and we really look forward for your active contribution as a part of our member. Thank you so much for spending your time from the weekend. Thank you, everyone. Stay safe and keep learning. Thank you.
Thank you.